If there was no deceleration taking place, u would be 39. But there's deceleration happening. Okay, so what happens is you go A to B and you go u vast. This is basically what I told you to do. U, A, S, and a t value of 1. Then you go AC. You go U equals U, V equals we don't know, A equals A, S equals what, guys?
2.
S.
Sorry, S is 37.
It's not. It's 76. And then my t value is 2. I'm then going to get these two data sets together. And what I'm going to do is I'm going to use simultaneous equations to find out the value of u and a.
Sir,
Yes.
why don't we fill in V?
Why don't we fill in a to d?
V.
Because I don't know what it is. And it's not this. I can't do this. I can't say that that's v and that's v. Because they're two different v values at different parts along the path. But u has a common starting point, which means I'm allowed to use u in both data sets. Is that okay?
And for A, like, we really see that goes down.
Now,
Go back to the question.
no, I'm just going to lock this out for a second, okay? So, s equals ut plus a half at squared. 39 equals u times 1 plus a half a times 1 squared. So it's going to be 39 equals u plus a half a. I don't deal with fractions, so I'm going to multiply both sides by 2. And that's my first equation. Then my second equation is this one here. And I'm going to do pretty much the same thing. It's going to be 76 equals u times 2 plus a half a times 2 squared. 76 equals 2u plus 2a. And I think what you're saying is going to happen, that the a value is in fact decelerating by 2. So what you're going to get is 76 equals 2u plus 2a. Do the green one take away the purple one? If you do the green one take away the purple one, multiply the purple one by minus, and you'll get minus 2 equals a. It's consistent with deceleration of minus 2, isn't it? Yeah. Now, in hindsight, I did use A to C though, didn't I? But I haven't proved C to D, have I? So in hindsight, what should I have done? I should have used data point A to D just to cover the full question. Does that make sense? Okay. Still can. Now, if I want to cover A to D, yeah, and they all give the same answers. So, if you will, A to D is the following. A to D, there's a U value of U, a V value we don't know, an A value. What the S value be, guys? S value, if I use A to D. Now, guys, we'll see if it balances, basically, right? You said it's 111, did you?
Yeah.
And we don't know the A value, do we? No? Relax for a sec. Okay, so what's our U value again? Do we only get the A value? We haven't actually got the... We haven't got the U value yet, have we? So what's 2A? Minus 4. 2u minus 4 is 76, implies that 2u is 80, which implies 40 is u. If you want to prove it for the last section, it's very easy. You could just say, look, that's 40, that's minus 2, and t value, what's the t value for A to D?
3.
3. You could just plug into ut plus a half at squared, couldn't you? and you could prove that it travels 111 and that it works all the way through the system. Does that make sense?
So 8 would be 6 seconds.
What?
It'd be 6 seconds.
Oh, it's 6 seconds because of.
Because like 8 to B is 1, then B to C is 2, and then.
I don't think so. 3 consecutive seconds. T is 3. Well, no, if it balances. If it balances, I'm right. If it doesn't balance, I'm wrong. Alright. Will somebody do 40 times 3 plus a half minus 2 times 3 squared? Fairly certain I'm getting 111 from that.
Yeah.
So I'm right. It works. And I just go. The answers of U equals 40 and A equals 2 works for all sections. Hence, it's the correct answer. Now, this brings us to the next part. U is 40. Are you happy that U is 40 and A is minus 2? What they're asking next is, how much further does it travel until the train's velocity is 0? How are you going to do that? We'll call this point E. Anybody have any idea how you're going to do that?
It's just S, so we don't know what's it.
Well,
You find
Has to
T
be
first.
Hmm?
I think you find T first and then you put in the S.
okay. So, two different ways of doing it. The first way is we could find out what the V value is here. See this point here? We could find out what is the V value after 3 seconds and set that as our new U value. And we could do U down to 0 and find that distance there. Would that make sense? So let's think about it. U is 40. V is what we're after. A is minus 2. And S is 111, isn't it? And I'm after V. T value of what? 3. What's the best way to get V? Your choice. Shh. You use V squared equals U squared plus 2AS, or what else can you use? V equals U plus AT. I think V equals U plus AT might be an easy one for us, will it? So what is it? 40 take away. What you reckon?
Minus 2 multiplied by 3.
What you get?
36.
34. So that means as you pass the point D, your initial velocity is 34. Now I can use DE. Now I'm using the data set DE. So what happens with DE, guys? What's your initial velocity? 34. What's your final velocity? Your A value? Minus 2. Your S value? Goal of the question, isn't it? Your T value? You don't know. And how much further will the train travel? Further, I assume, how much distance? Would that make sense? So how are you going to do that? Ideas?
Get B.
You could get T using V equals U plus AT and sub that T into S equals UT plus a half AT squared. I'm lazier than you. I want to do it faster. Any ideas?
B squared equals U squared plus 2AS.
Yeah, I'm going to do it this way. So what do we get? Well, 0 squared equals 34 squared, yeah.
2 minus 2.
I'm going to call the distance x, is that okay? Because my s's look like 5s. And you're going to get 34 squared is, well done. Bring the 4x to your side, divide it in,
289.
2, 8 meters. Takes a long time to slow down, doesn't it?